It is one of the most beautiful and majestic planets in the solar system. With its pale amber disk and bright glittering rings, it's also one of the most recognizable planets in the heavens. Saturn, a symbol of all that is exotic and wonderful about the universe. Once, this magnificent world was the most distant planet we knew of, a mystery seemingly beyond our grasp. But now, we have finally reached out to this ringed giant. We have circled among its icy moons, explored its storm clouds and the swarming particles of its rings, unmasked its secrets, and brought it at last to within our understanding. It is a part of the long human journey of exploration. A journey where each new destination leads us to a new appreciation of the glorious universe that beckons beyond the shores of Earth. In 2004, after a 7-year roundabout journey through the solar system, Cassini was the first spacecraft to fall into orbit about Saturn, becoming a new moon of the ringed planet. The size of a school bus, Cassini is one of the largest and most sophisticated unmanned spacecraft ever sent skyward. Its suite of 18 separate instrument packages studied Saturn, its rings, its moons, and its magnetic environment. The distance separating Earth and Saturn is so great that Cassini's radio signals take almost an hour and a half to cross the nearly 1 billion miles of empty space between them. Scientists and engineers are still studying these data and sharing their findings with the world. Their work, and that of Cassini, is the continuation of a curiosity about the ringed planet that goes back centuries. For thousands of years before the telescope, when the sky was a mirror for the gods, Saturn was well known as one of the 7 ancient wanderers among the stars. The sun, moon, and 5 visible lights that the Greeks would eventually call planets could be tracked along the backdrop of constellations. To the ancient Babylonians, the slowest of these wanderers was Ninib, named for a god of war. Later, the Greeks and Romans beat his sword into a plowshare and called him Saturn after an agricultural deity. But no one would guess the true nature of these wandering lights for many centuries more. It was not until the early 17th century when the Italian scientist Galileo Galilei turned the newly invented spyglass to the heavens that humanity began to see the planets as other worlds. Through his crude telescope, Saturn appeared as a triple world, a larger body with 2 smaller companions that he called attendants on either side. 2 years later, Galileo found that the attendants were missing and wondered if Saturn had devoured his own children. But when he looked again a few years later, they had somehow returned. Saturn's peculiar appearance and behavior puzzled astronomers for decades. It wasn't until 1655 that the astronomer Cassini-Huygens, with a much better telescope, determined the true nature of the planet's unusual companions. Huygens correctly described them as a thin, flat ring, nowhere actually touching the body of the planet. It was the inclined nature of the ring that had confounded Galileo. Saturn, like Earth, is tilted on its axis, and as the planet orbits the Sun, the apparent tilt of the ring changes when viewed from Earth. When Galileo noted Saturn's missing companions in 1612, it was simply because the ring was then edge-on to Earth, making it nearly invisible. For decades afterward, astronomers debated the physical nature of the ring. Was it solid, liquid, or gaseous? It was not until the late 1800s that scientists, using far better telescopes, were able to determine that the ring was made of individual particles orbiting the planet. They also noticed that these particles were far enough apart from each other that stars were able to shine through. Since the invention of the telescope 400 years ago, Saturn has remained a fascinating target for amateur and professional astronomers alike. Today, a small amateur telescope with a magnifying power of only 30 times will show the rings better than any view Galileo ever had. A medium-sized telescope with modest power begins to reveal the subtle cloud bands in the planet's chilly atmosphere. It also shows the dark division in the ring that was first recorded by another Italian, Giovanni Cassini, in 1675. This rift was found to be a gap in the ring and is now known today as the Cassini division. It separates Saturn's broad ring into two parts, the outer A ring and the inner B ring. A careful observer today can also notice a faint star-like object that never strays far from the planet. This is Titan, discovered by Cassini-Huygens in 1655. Titan is the largest and first of Saturn's moons to be discovered. Giovanni Cassini found 4 more, and many others have been discovered since. Icy worlds circling a cold and dazzling parent 900 million miles from the Sun. For all that we can see through our modern-day telescopes, Saturn's great distance and the optical distortions created by our turbulent atmosphere restrict our Earth-bound view. But with the arrival of the space age, all that changed. In the 1970s and 80s, spacecraft from Earth made their first brief flybys of the great ringed planet and expanded our knowledge of this world far beyond the limited details observable from Earth. Pioneer 11, and especially the 2 Voyagers, in their fleeting encounters with Saturn, revealed a planetary system far more complex and dynamic than we had first expected. And while these brief glimpses left us with an unforgettable impression of the phenomena waiting to be discovered, they also gave us a sense of scientific riches just beyond our grasp. Scientists soon realized that Saturn and its companions offered what no other planetary system had before: a chance to witness the same evolutionary processes at work today as those responsible for shaping the early solar system. It was clear we needed to return to the great ringed planet. This time, to stay. Our answer to this challenge was the Cassini-Huygens spacecraft, named for the astronomers who used the best technology of their day in an effort to understand the planet that had once perplexed Galileo. Launched in 1997, Cassini-Huygens was the largest, heaviest, and most complex interplanetary vehicle ever built, carrying instruments for 27 separate investigations and more than 3 tons of fuel. For 7 years, it used the planets Venus, Earth, and Jupiter in a game of gravitational slingshot to achieve the right speed and trajectory to reach its target. Then, in 2004, after a journey of more than 2 billion miles, Cassini arrived at its destination. It fired its engine in a long, gradual burn, slowing itself enough that it could be captured by Saturn's gravity. Cassini has now flown by Titan more than 40 times, not only to study the moon close up, but for gravity assists into different orbits. This kind of navigation allowed Cassini to visit almost any part of the Saturnian system with a minimal expenditure of fuel. Each orbit was carefully designed so we could study Saturn, its rings, and its magnetic field from a variety of locations, as well as make close passes of Saturn's other major satellites. So what secrets has Cassini revealed? Saturn is a giant spinning ball of gas, an envelope of compressed hydrogen surrounding an Earth-sized rocky core and blanketed with a thick, cloudy atmosphere. Second only to massive Jupiter in size, it dwarfs our own Earth, which would seem but a cosmic pebble beside this huge world. Saturn's atmosphere is a multicolored soup of cloud bands, Earth-sized hurricanes, and jet streams with winds exceeding 1,000 miles per hour. The atmosphere is mostly hydrogen and helium, muted by a frigid haze where the cloud top temperature lingers at 200 degrees below zero. Active regions at its north and south poles reveal strange hurricane-like whirlwinds over 50 miles deep, with winds circling at 350 miles per hour. The circular and oblong clouds dotting this image are likely the result of upwelling air from deep inside the planet. This air helps power the cyclones. The clear air of the vortex eye is an area of downdraft large enough to swallow 4 Earths. Despite its great size, Saturn spins on its axis more than twice as fast as Earth, completing 1 rotation in just 10.5 hours. Rotating with it is an enormous magnetic field generated deep within the planet, creating a monstrous region of magnetic influence called a magnetosphere. Its shape and character changes with the buffeting of the solar wind. Saturn's fabled rings provided some of the biggest surprises. Prior to the Voyager encounters, we knew of only 3 broad rings spanning a total distance of more than 200,000 miles. The Voyagers and Cassini discovered that the main rings were themselves made up of thousands of discrete ringlets, each consisting of icy rubble and debris. This rubble is thought to be kept in place by the numerous gravitational tugs of Saturn's outlying moons. In fact, a thin braided ringlet lying just beyond the edge of the main rings, and now called the F ring, is shepherded by a pair of small moonlets on either side. Their gravitational nudges are sufficient to keep the ring particles narrowly grouped together. There seem to be other forces at work on the rings as well. The Voyager flybys revealed dark, spoke-like structures that appear to be traveling through the brighter ring material. Could they be caused by Saturn's rotating magnetic field interacting with tiny dust grains in the rings? The fact is, we still don't know with any certainty the source of this strange phenomenon. And yet, despite the rings' vast span and complex structure, the thickness of the rings is no greater than the distance between the goalposts on a football field. They are so thin that they all but disappear when seen edge-on from Earth. From a distance, the rings may appear solid. In reality, they are an enormous blizzard of countless chunks of ice and ice-covered rock that range in size from snowflakes to icebergs. Each races around Saturn at speeds of up to 50,000 miles per hour. Such a setting of great beauty, enormity, and complexity naturally begs the question, how did these rings form in the first place? Observations from Cassini indicate that the rings may have been created when a moon was shattered by an impact into countless fragments. These eventually spun out into a disk. The pieces continue to reassemble themselves, forming small moonlets which are then shattered to form new ring material, a recycling process that makes the rings constantly appear new. The rings exist today as swarms of orbiting particles like so many trillions of tiny moons. Yet Saturn has an impressive family of large satellites as well, one of the most diverse and intriguing collections in the solar system. Saturn's unique family ranges from tiny moonlets no bigger than a town to Titan, the second largest moon in the solar system, bigger even than the planet Mercury. Titan is the only moon in the solar system to have a significant atmosphere, and the only place other than Earth where the air is mostly made of nitrogen. Titan's atmosphere is polluted with a smoggy orange haze of organic molecules, so much so that its cold and mysterious surface was completely hidden from the Voyager's view. In early 2005, 6 months after entering orbit around Saturn, the Huygens probe detached itself from Cassini and parachuted to the surface of Titan. At last, the surface of this primitive world was open for direct study. Landing in what's been described as Titanian ice gravel, Huygens photographed chunks of water ice up to 6 inches across and found evidence of erosion at the bases of these chunks, possibly caused by a flowing liquid. Titan's atmosphere is a mixture of chemicals that scientists think are similar to the atmosphere that existed on the early Earth, here preserved at a temperature of nearly 300 degrees below zero. Titan's methane rains, ethane lakes, and organic sludges are a snapshot of what Earth was like long before life arose, and offer clues to how our world became a life-bearing planet. Titan is not alone in harboring wonders and mysteries among the fantastic moons of Saturn. While many of these satellites are more ice than rock, they also possess an array of incredible features, including deep canyons, towering cliffs, and wispy surface colorations. Enceladus orbits Saturn in the middle of a thin, broad sheet of particles called the E-ring. Cassini's cameras revealed what scientists had long suspected. Icy jets erupting on this moon supply the E-ring with a constant supply of ice particles, while at the same time resurfacing the moon's terrain. The greenish areas are believed to be deposits of coarse-grained ice, while the whitish ones represent finer-grained ice. The coarse-grained deposits are concentrated along valley floors and walls, as well as along the upraised flanks of the tiger stripe fractures. They are likely the fallout of nearby geysers of ice. In a feat of interplanetary sharpshooting, Cassini even pinpointed precisely from which fractures the icy jets are erupting. These huge fissures are nearly 1,000 feet deep, with steep, V-shaped inner walls. Scientists are using images like these to discern whether reservoirs of liquid water may exist beneath the surface of this strange world. The tortured surface of Enceladus is a masterpiece of deep time and wrenching gravity. Its geologic activity tells a fascinating story of a tiny world in constant struggle, both ancient and ongoing. The second largest moon of Saturn's family is Rhea. Its cratered surface, already ancient before any complex life developed on Earth, has probably changed very little in the past billion years. One of the most distinctive characteristics of this moon is the white streaks across its surface. These bright, wispy markings cover its trailing hemisphere and are thought to be luminous icy canyons created by frost venting from cracks in its frozen crust. Dione is also heavily cratered and streaked with white, wispy markings. The wisps were once thought to be thick frost, like that found on Rhea. But scientists have now discovered that they are actually shiny ice cliffs created by tectonic fractures in Dione's surface. Thanks to the close flybys of Cassini, we now have splendid views of Dione's braided canyons and their steep white slopes. Tethys is split by an ice canyon, 60 miles wide, several miles deep, and stretching nearly pole to pole. Known as Ithaca Chasma, the ridges around this huge gorge have been thoroughly hammered by multiple celestial impacts. Bombardments such as these suggest that Ithaca Chasma is very old indeed. But this great rift is not the only spectacular scar on Tethys. The Odysseus impact basin on the opposite side of the moon is over 250 miles wide, or nearly half of its leading hemisphere. This basin has slightly fewer impact craters, suggesting that it is a younger feature on Tethys than Ithaca Chasma. Mimas bears a giant crater so large that it covers 1/10 of the surface area of this small moon. The impact that created it was almost powerful enough to shatter Mimas completely. Known as Herschel Crater, its central peak is over 4 miles higher than the surrounding crater floor. The view from the surface of Mimas is spectacular, with Saturn and its rings filling up more than half the sky. Hyperion is irregularly shaped, almost looking more like a deformed potato than a moon. Its rugged surface is dominated by towering cliffs more than 6 miles high. Close-up views reveal a world that has been bombarded by meteors for eons. Scientists now think that Hyperion's spongy appearance is due to its unusually low density. This gives it a weak surface gravity and a highly porous exterior. This also limits the amount of material that is blasted into space during impact and keeps what is expelled from falling back to the moon's surface. This combination of low gravity and low density may have helped preserve the original shapes of Hyperion's craters. Phoebe is a small, scarred world. Its jagged surface is covered with tremendous landslides and deep impact craters. These avalanches reveal crater walls covered with bright water-based ice and patchy clusters of silicate and organic material. The presence of such volatile ices suggests that this tiny world may have first formed in the outer solar system, far from Saturn itself. Much later, it was captured by Saturn's gravity during a chance encounter. because it is a remnant of the formation of the solar system, Phoebe is much older than Saturn itself. Iapetus is a two-faced moon. Its leading hemisphere is as dark as coal, while its trailing hemisphere is as bright as snow. Scientists think Iapetus's two-toned appearance may be an example of thermal migration. The material on the dark side is warm enough to release small amounts of water vapor. This vapor then drifts over to the brighter and colder regions of Iapetus, such as the moon's poles or its brighter hemisphere. When cooled, the water vapor condenses and falls to the surface as ice. As the dark material loses its surface ice and gets darker, the bright regions accumulate ice and get brighter. Perhaps the most remarkable feature discovered on Iapetus is a mountainous ridge that coincides almost exactly with its geographic equator. This ridge is a conspicuous band that extends more than halfway around the moon, giving it a walnut-like appearance. The peak of the ridge can reach over 12 miles above the surrounding terrain. The geologic forces that cause this unusual ridge still remain a mystery. Does this mean we have learned all there is to know about Saturn? Not by any means. There are many more unsolved questions to answer, as well as new mysteries that have yet to be discovered. The Pioneer and Voyager flybys, the Huygens lander, the Cassini orbiter, these were merely our first attempts at trying to comprehend this great ringed planet. Future missions may release probes into Saturn's atmosphere or land on its moons. One concept, for example, would deploy a blimp to cruise over Titan's surface. Such an aircraft could carry out aerial mapping, drop telemetry packages, and then send its data back to Earth. In the past, Saturn was only a destination of the imagination. As we extend our presence further into the solar system, it is possible to imagine a time in the not-too-distant future when Saturn and its moons are a destination for us. The past has often shown us that what once seemed like science fiction often becomes the reality of the future. What may seem like distant dreams today could very well become the world our great-grandchildren live in. These dreams represent the motivations, hope, and outlook of our future generations. Viewing Saturn through a telescope is an inspiring sight. It is an invitation to explore the universe. So the next time you look at Saturn, that bright, pale yellow orb in the night sky, the one our ancestors once called Ninib, remember that it is a place of wonder, a place of mystery, and a source of inspiration from which future generations will create their own dreams of discovery.